Okay, I'm going to talk to you about Cloud SQL. I actually have a special guest at the back of the room. Joe Faith is the PM for Cloud SQL, so he will keep me honest. And okay, so this is what we're going to talk about. This isn't a real long presentation. So the first question, obviously, what is Google Cloud SQL? It is MySQL running in Google's cloud. That's, in a way, all you need to know. If you know MySQL, then you know how to use Google Cloud SQL. So you don't really need to attend this lecture, so you're welcome to go. Okay, so why did we pick MySQL? Well, SQL is got a very long history. Lots of people know it. It's all about keeping the learning curve down. There's tons of information. We picked MySQL because it is the world's most popular open source database. Has a very friendly user community. Basically, people know it. People already know it. We don't want to make you learn something new. It's for those people who want to use SQL. We have a cloud offering for you. Very quick quiz. Does anybody know where the name MySQL came from? Why My? It's actually the name of the founder's daughter. Wally knows the answer to this. Yeah. Okay. Yeah, the daughter of the co-founder, I forgot the co-founder's name, his daughter's name is Mai. Yeah, that's right, Wally, yeah? Yeah. No, his daughter's name is Mai, and he stuck it in front of SQL. Okay, so some of the key features of Google Cloud SQL. It's open standards based. If you know SQL, you know how to use it. It comes with Google level security, so all the security that we have, your database, you put your database tables into our cloud, they're really secure. We have really great intrusion detection software. It's easily accessible. There's a variety of ways to access your Cloud SQL instance, and I will go over those in a minute. There's a UI, there's command line tools, third-party tools. You can access it programmatically from App Engine or from any other application, so you can connect to it, just like you can connect to your MySQL database wherever it happens to be hosted. You can connect to it in the cloud. And when you're developing on App Engine, you can either develop you can connect to Google Cloud SQL running in the cloud, or you can just connect to a local MySQL instance on your workstation. Keeps the cost down a bit. So ease of administration. Basically, Google does the administration for you. How many of you guys have actually had to administer SQL databases? Okay. All right. Well, if you'd had your database in Google Cloud, you wouldn't have had to spend any time administering it at all. We take the worries out of it for you. It's a full database as a service with the software and the hardware. It's highly available. It's automatically replicated. We keep your data really, really safe. You're not going to lose your data with us. You can schedule backups to your own schedule. We do the automatic replication, but you can schedule backups if you want them as well. And we have some nice admin tools. So a quick look at replication. This is just showing us that every time you write some data to the database, it gets replicated in multiple places. It keeps it really safe. The replication happens when you do the write. So you can choose whether you want it to be synchronous or asynchronous. If it's synchronous, it's updated right away. If it's asynchronous, it might not. The replication isn't quite as quick. I mean, we're talking fractions of a second here, and there's a very small chance you might lose just a tiny bit of data. But you can choose it. And actually, this is how you choose it. There's a UI. You can say synchronous or asynchronous. So we replicate your data for you, but if you want backups, like you want your own snapshots, you can schedule backups. Again, the UI is very simple. You just choose your time window, and we will back up your data in that time frame. I think the backup will start within the time frame that you choose, sometime in that time gap. So importing and exporting databases is, you actually have to import and export through Google Cloud Storage. So you can, it's not hard, but you have to put your data into Google Cloud Storage to get it into Cloud SQL. And when you export it from Google Cloud SQL, it goes out to Cloud Storage. And then from there, like you guys already know all about Google Cloud Storage, you can just download it or use GeoUtil with it or do whatever you want with it. But we do use Google Cloud Storage as the staging mechanism for importing and exporting. So yeah, to import, you just basically export your existing database, put it into Cloud Storage, and then import it. And then if you're exporting, the one thing to know about exporting is that you have to export the entire instance. You can't export individual tables. You export the whole thing, shove it all out to Google Cloud Storage, and then do with it what you want. So I'm going to talk a little bit about the differences between Cloud SQL versus MySQL. And the differences basically are around the fact that we're running, that Google Cloud SQL is running in the cloud. It's not running on your workstation. It's not running on a server on your company's premises or anything. It's up there in the cloud. In the database, data centers. So the basic differences are around the connection handling and yeah, so it's basically the connection handling. And the other thing is that to help you keep your costs down, if you have a Google Cloud SQL instance and it's not being used, if it goes idle after some amount of time, it's actually shut down. So it's not running up charges for you when it's not in use. So the fact that the instances go down when they're idle and then they come back up when they're needed again, it's just a slightly different way of thinking about it. Doesn't make that much difference. Does keep your costs down, but it's something to be aware of. And if your instance goes idle, then the next time a request comes in that needs the instance, the very first request has a little bit of a warm-up time needed for it. The connection URLs are different, but only in the actual syntax. The port for connecting to in the cloud is different. All the prepared statements are server-side, and the default storage is InnoDB. You can actually use others, but we highly recommend that you stick with InnoDB. Yes, it all runs on the server side. So, I just said that if you know MySQL, you know how to use Cloud SQL. That's true, but there are some slight differences, and the differences again are basically to do with the fact that your Google Cloud SQL instance is running on our data centers and not on your local stations. So. And you don't need the replication. So any functionality in SQL to do with replication, we don't support because we do the replication for you. Things like loading files, there isn't really a concept in Cloud SQL, so we don't support those kinds of things. Don't support plugins. But does that make sense? It's just kind of high-level differences. The absolute complete list, this is more or less the complete list. Do you have anything to say, Joe? Some restrictions to super user privileges, but apart from that, this is the list. Okay, so now I'm going to talk about how you access your Google Cloud SQL instance. There's different ways to access it. If you want to administer it, like create your instances, schedule your backups, that kind of stuff, We have a nice UI for it. We also have an admin API, so you can do it programmatically if you want to. And then if you want to access your database tables, which is obviously why you have a database, right, to get data in and out, we have a SQL prompt in the API's console, so you can do it interactively. We have command line tools, just like in Reuters was a command line tool. Well, Cloud SQL has a command line tool, and then you can access it programmatically from your applications. So, I think you guys have already got it by now that we have these two different consoles. We have the existing API's console, and we have the new Cloud console. And there's still some functionality that exists in the API's console that isn't yet in the Cloud console. Every time I use the Cloud console, it's a lot better. But it's still, it's still going through some growing pains. So this is the old API's console, and this does include a SQL prompt, so you can type SQL in here. But then, so the API's console, you can administer your database, you manage your billing, you set the authentications, all that stuff. And so in the API's console, this is just the interface. This is when you're creating the instances, you specify the settings, and then later on you can come back and you can manage your settings. I just want to show you this so you can see there's a very simple UI for it. So then it's pretty similar in the Cloud console. I mean, the layout of the console looks a bit different, but the functionality is pretty much the same. The one exception in the new console is that it's not going to have a SQL prompt. Is that right, Joe? Yeah, there's not going to be a SQL prompt in our UI console, but there'll be other standard SQL consoles you can use, right? So again, this is just, in the Cloud console, you create your instance, you manage your settings, you edit the settings here. Okay, so now I'm going to talk about the command line tool. So this top picture is just the SQL prompt in the API's console. And then we have a tool called Google SQL.sh that lets you, from the command line, lets you connect to your database and run queries. So this is just showing you that from the command line, from the command line, you can do exactly the same stuff as you can do in the interactive prompt. Yes, question. Google SQL, no, it's the same thing. I mean, there's SH, there's PY, and I think the Windows one is different extension, but the same. But it's basically the Google SQL tool. So when you're integrating from App Engine, up until fairly recently, the way you had to do it was use the App Engine SDK and connect through the SDK. We've recently introduced the capability to use native MySQL APIs. So the exercise that you're going to go through actually uses the App Engine SDK way. I think they're pretty similar, actually. It's just the way you connect that's different. So when you're accessing from App Engine, first of all, what you have to do is you have to, in your console, whether you're using the Cloud console or the API's console, you have to let the project where your Cloud SQL instance is, you have to let the instance know which App Engine applications are allowed to access it. So the first step is to go into the console and to authorize your App Engine applications. And the other thing is that we try to optimize performance when your App Engine application is using a Google Cloud SQL instance. We try and keep them as close together as possible. So your Google Cloud SQL instance will live with, or as close to as possible, the first App Engine application instance in the list. So if you have multiple App Engine apps that want to connect to your Google Cloud SQL instance, you should make sure the one that's going to connect to it the most often is at the top of the list, because it's going to become your Cloud SQL instance's best buddy, and everywhere your app goes, the Cloud SQL instance is going to go too. So you want to make sure it goes with the one that, that it interacts with the most. And if you create your Cloud SQL instance and you don't authorize an App Engine application, that's perfectly fine. But then if later you come back and you add an app, you authorize an App Engine application to use it, if those two aren't close together already, your Cloud SQL instance will be moved to join the application. So hopefully this might make it a little bit clearer. So in this example, we have 3 different regions in the US, and we have a MySQL instance. It has an App Engine application that connects to it. Well, if this App Engine application gets moved to a different data center, then the MySQL instance will be moved with it to try and help keep the latency low. Okay, so you can also connect to you can use MySQL APIs to connect to Google Cloud SQL. So this is just how we do it. Whoops, sorry, I keep pressing the wrong thing. You use MySQL DB for Python or MySQL Connect to J for Java. We want to be as consistent. We're trying to be as consistent as possible with standard drivers. So a lot of the changes that we're making in Google Cloud SQL are to make us more standard and move away from anything that's not standard. So there's links in the slides. You'll find these links quite useful, I think. The Getting Started guide. So we can connect from third-party tools to Google Cloud SQL. There's a bunch of them out there. This one's just an example. It shows Squirrel, or I don't know how you say it, SQ, Squirrel, whatever. So in this case here, what you need to configure it, the third-party tool, to connect to your instance. And in this case, we're using the MySQL API driver and running it on the dev server. But you need to put the appropriate URL in there. And that's pretty much all you have to do to configure it. So the third-party tools, it's usually pretty simple configuration to get it to connect to your Google Cloud SQL instance. Say that again? Are the replicas or slaves accessible? No. No, we just replicate your data for you, and you connect to the instance. But do you have something to say, Joe? He looks like he wants to say something. Yeah, can you take the microphone?
So yeah, this issue of replication is kind of at the heart of what makes Cloud SQL different. In some senses, yes, it's just MySQL 5.5, familiar, widely used. But what makes it googly, what makes it cloud-enabled, is how the storage is replicated. Every byte that you give us, every byte that you give the instance, is saved in multiple locations, in multiple data centers, which means that half a dozen hard drives could crash. A data center could be taken out. 2 data centers could be taken out and their entire network connectivity. And your data will still be there, still safe, still serving. Your database will still be available. That is what makes it cloudy, that we are above the level of the single machine, that the single machine is a brittle container, and that we've engineered a degree of redundancy, which means you don't have to worry about that. Yes, so the normal way of doing MySQL replication is that you've got two or more MySQL instances, and you send traffic from one to the other. In this case, there's a single MySQL instance that's saving the data in multiple locations, which means we can then move the instance wherever you like. So it's not replication for read scalability, it's for durability and availability. So, sorry. No. No. It's the storage is done. The replication is done at the storage level. One thing I wanted to talk about on this issue of replication, if I might, is that Jocelyn talked about we want to make it as standard as possible. We want to balance the making it as cloudy and as googly as possible, but still being as standard as possible. So what we're launching very soon is the standard MySQL wire protocol, which is the standard way of connecting to any MySQL database. So once that's launched, you can connect to MySQL using any application from just about anywhere. The Trusted Tester program is open at the moment, so contact any of us and they'll put you in contact with me and we can get you enrolled into the Trusted Tester program. This gives you a bunch of stuff, and I'm coming back to the point about replication in a moment. This gives you a bunch of stuff. So for example, very low latency connections from GCE. At the moment, originally, Cloud SQL was primarily used from App Engine. Now we're now opening up to GCE, you get much lower connections, lower latency connections. And again, the multiply replicated footprint means you can ensure lower latency connections from GCE. Secondly, a bunch of stuff that I was using standard tools like the MySQL standard command line tool, which everyone uses all the time, rather than the Google specific one, which is part of the reason why we're no longer having the SQL prompt. We thought, well, why have our own special SQL prompt when you can just use the standard MySQL tool, which everyone uses all the time. And the other point I was going to make is about migration on and off and replication. Now we've opened up the standard MySQL wire protocol, you can do a lot of nice stuff like migration on and off the platform with no downtime, because you can replicate from MySQL instance out to from a Cloud SQL instance out to a standard MySQL database, or the other way, or replication between Cloud SQL instances. We can talk about that in more detail if you'd like, but this is going to make it a lot of stuff more flexible and more possible. So we're trying to combine, the basic offering is single instance, data stored in many locations, so it's not going anywhere, that data, and we can serve from many locations. Yeah. But once we open up MySQL wire protocol, this will be the first step in making that happen. I could talk more detail about that if you'd like, how we're going to make that happen, but that's the direction we're going. Okay? And I think that was it.
Okay, great.
So the standard connectors like JDBC or ODBC or connectoj.net and all those, they work on top of MySQL wire protocol. So if you go to the MySQL site, there's just a long list of standard connectors for every language you'd like, and they all work on top of the MySQL wire protocol. I've yet to come across an application. When I say it works from any application anywhere, I'm sure there's going to be some application that doesn't work with it. So I'm saying that, and I think that's true, but just about anything, just about anywhere. Oh, yes?
Just a quick question. A while back when I tried it, there's quite a bit of latency from App Engine during setting up and turning down the connection. Has that been minimized at all? Or is that
For actually for creating the connection, and what was the framework? What was it? What was this from?
we were doing like SQL alchemy to MySQL.
Which
We were
one?
seeing that we had to, we were about 500 millisecond connection when we were doing it. It was a while ago, so I don't know if it's.
Right. I'm not that familiar with SQL Alchemy. I'll have to dig into it. Well,
It's just using the standard Python DB connector.
okay. We did know some people were having some pain from Django, and it turned out that Django wasn't caching the connections. Didn't have a connection pool configured. And in other cases, this is the thing you get with frameworks, that they make a lot of stuff easy, but when something goes wrong, it's hard to work out where the problem was. I'm happy to chase it down with you, but you shouldn't be seeing those sorts of connection times. So I'm not sure where that's coming from. But Pardon? Number of connections at the moment, it's a 100 simultaneous requests, because then you start running out of threads. Once we move to MySQL wire protocol, then there's effectively no limit on the number of open connections, but the number of actual requests that the processor can be doing at the same time is obviously limited by your MySQL server. So the more CPU you give it, the more simultaneous requests it will be able to do. But just in terms of number of open connections, the sky's the limit. I mean, if you're hitting those limits, then there's probably a bug on your side, that there's probably, you're not closing connections cleanly. In terms of limits on IOPS, it's running on hard drive, so it's in the low hundreds ultimately. But you can scale up the amount of RAM and CPU so that as long as a high proportion of your requests are hitting buffer cache, then you can get, we've got large, I won't mention any names, we've got large customers running very large e-commerce sites quite comfortably on national sites on Cloud SQL. If you've got a super scale application for which you do need the thousands of IOPS, we are looking at solutions in that space, and I'd be very interested in talking to you if you've got a particular use case where you need that. Okay. Okay. Yes. Yes. So going forward, when we've got MySQL wire protocol, we've got options to have read replicas, and also, as I say, looking for very high IOPS versions.
Thanks, Joe. Okay, so yeah, you can connect from third-party tools. Let's see, what are we up to next? Okay, just going to talk a little bit about some best practices. First of all, you might want to know, is this right for me? So, I mean, one of the reasons it's right for you is if you know MySQL, you know SQL, you're comfortable with it, you have databases, some of it comes to do with, is there a learning curve for you? And in particular, we do have a 100 gigabyte limit per database. So, we support up to 100 gigabytes. Like Joe said, there'll be something, there's something coming to handle bigger ones. But right now, we have the 100 gigabyte limit. Best performance tends to the thousands of queries per second. So, and then this is always a hot topic. Should I use Cloud SQL or should I use the App Engine data store? So, anybody want to answer that for me? Anybody want to give me a case where you might want to use Cloud SQL instead of the App Engine data store?
When you have complex queries like joins and everything, I don't think data store would be a feasible solution.
Okay, another one. Who wants to defend data store?
If you have an existing application and you want to bring it to the cloud platform, it's already using a traditional relational database, that would be a good way to get an entry.
I was just going to say, from a data store standpoint, a lot of the parallel queries or asynchronous queries and stuff that you can do are very scalable. So we've used that a lot to get pretty incredible performance.
Yeah, so data store does scale much faster, much more. But it depends what you want to do. If you need the reports, if you need the full SQL query language, then Cloud SQL will be the better option. And anyone else want to talk about applications that they think would be better in Cloud SQL versus data store? Yeah. Ah, that's another one. What about versus BigQuery? Yes. BigQuery, you all know about BigQuery now. BigQuery supports a lot more data than Cloud SQL, but it's also not, the real time. I mean, basically with BigQuery, you bring in a ton of data and then you analyze it. BigQuery is not a place where you create and update your data. I mean, it's not, BigQuery is read-only. So there's, again, there's different use cases, but, again, it can be confusing. So, and anybody want to say something about BigQuery versus Cloud SQL? Joe, you want to say anything about BigQuery versus Cloud SQL? Okay. Okay. So yeah, and if you need, if you need the transactions that Cloud SQL gives you, yeah. So you can, if you get the right people, they can talk about this for a really long time. Okay. So connection handling. Yeah, you don't need the conventional connection pooling. I mean, part of it is that when your instances are idle, they go down. So if you have a connection to an instance and it goes down, then that connection will be blocking. So it's much better to create the connection when you need it, close it when you're done with it. And in tests, it turns out that using a new connection versus keeping the connection alive and reusing it takes about the same amount of time. You create a connection at the start of a request, you close it at the end. I think this data here, the max 100 concurrent calls, and then the unlimited open connections will apply when the MySQL wire protocol comes out. So MySQL uses InnoDB as the default database engine. Some databases, some of your databases might use MyISAM. MyISAM only caches the index, doesn't cache the data like InnoDB does. So we strongly recommend that you use InnoDB. When you create Cloud SQL instance, it's not a problem. It's going to use InnoDB by default. But if you're bringing in data from a different database, if that database uses MyISAM, you may want to convert it to use InnoDB. And we recommend, if you're using App Engine, to enable the auto commit for the database transactions. It's the default in Java. It's not the default in Python in the DB API. It's also one of those things that, like, if you forget to commit your transaction and the data doesn't get saved, you can spend hours, days debugging your problem, and it's just because you forgot to auto commit. So it's just a recommendation by some of our software engineers. Save yourself some headache and enable auto commit. So we recommend for performance tuning, bear in mind that your Cloud SQL instance is living on a virtual machine. It's not on a local workstation. It's not on a workstation down the hall. And when things go into the memory, it gets slower. So try and keep your query. Try to avoid queries over data sets with more than 20 to 50 million. And just remember that virtual disk is slower. And be careful when you're batching your read and writes, because we do have this wide area replication, and it can slow down the read and writes a little bit. This is only going to really affect you if you have big amounts of data. So app frameworks. I'm not really going to go into this in much detail. Basically, just want to make the point that Google Cloud SQL does support app frameworks, and usually, whichever framework you're using, what you really need to do is, configure it, and usually the configuration is pretty simple. Set the connection pool size. This is an example of Hibernate. We support Django. So you have to go in, you have to edit your project's app.yaml to enable it. And then if you're using the MySQL APIs, the connection point for the the Cloud SQL is just going to be slightly different depending on whether you're running your App Engine in production or on local host, and whether your MySQL is a local MySQL running on your development workstation, or if you're actually connecting to the Cloud SQL on Google's infrastructure. And that's it. Any more questions? Any more questions for Joe in particular? No? Okay, so in this exercise, you're going to work through using the interactive SQL prompt and the Google API's console to create an instance. You're going to practice importing a database. You'll have to bring it into cloud storage and import it into Cloud SQL. We have created the database for you. Don't worry, you don't have to go ahead and create one. And then there's an exercise for integrating it into Conference Central.